In this video, we're going to determine if a graph is realistic for a situation. Consider the following scenario. A flag ceremony is held at the 4th of July event. The height of the flag is a function of time. First, think about how the height of a flag could change over time to consider what kind of graph would best represent the situation. Then consider what the possible units could be. In this scenario, height could be measured in meters and time could be measured in seconds. Let's look at some graphs that could each be possible representations of the function. Graph A is a linear graph. In the context of the problem, it represents the flag starting on the ground and then immediately being raised at a perfectly constant rate. This graph would be considered possible, but it's unlikely that the flag would start on the ground and then move so perfectly smoothly. Graph B is a constant graph. In the context of the problem, it represents the flag starting out at 3 meters above the ground and then staying at that height the entire time. This doesn't seem very realistic for a flag ceremony. The flag starts at one height and never changes from it. This would be considered an unrealistic graph of the situation. Graph C is a nonlinear graph. Since it doesn't have a constant rate of change, in this scenario, the flag starts out on the ground but gets pulled up quickly. The movement slows down, and there is a brief pause, and then it is raised again at a quicker rate. This graph would be considered possible, but it's unlikely that the flag will start on the ground, and its speed probably won't keep going up so much. Graph D is also a nonlinear graph and has several horizontal intercepts. In the context of the problem, the flag starts out on the ground and is raised up a couple of meters and then is lowered back to the ground. This happens repeatedly. While this is possible, the graph would be considered an unrealistic graph of the situation. Even if the time were in minutes or hours, the scenario of the flag going up to its max height, immediately going back down, touching the ground, and then immediately being raised up again is unlikely. Graph E shows starting at 0.5, then increasing a little bit, pausing, and then increasing again. This repeats until the graph is at 6. In the flag ceremony scenario, it would mean the flag started out at half a meter above the ground and then being raised up bit by bit, with a brief pause before it is raised farther. If you have ever seen someone raise a flag, you can understand how this graph is the most realistic. When a flag is being raised, there are frequent short pauses. Graph F shows the height starting at 0, increasing at a perfectly steady rate until it reaches 6, and then decreasing at a perfectly steady rate until it stays at 3. In the context of the problem, that would mean the flag starts out on the ground and is raised at a constant speed for 3 seconds. It stops abruptly and comes back down at a constant speed. Then, 2 seconds later, it stops at 3 meters above the ground. This graph would be considered possible, but it's unlikely that the flag would move this uniformly up or down.